So you know what a parabola looks like. You know that inside, let's move this over a little bit. You know that for anything that's y equals x squared, we know that it's always going to be some sort of an up like a cup. If that value of a is negative, it would then be down like a frown. Do you remember when we talked about this value of a, what it did to the parabola? So if the absolute value of a is really, really big, is our parabola skinny or wider? Skinny. Think about it. If it's just y equals x squared, if x is 1, y would be 1. If x is 2, y would be 4. If I throw an a value in there that is larger, it just means it's moving up faster and faster. Yes, sir? I suppose. That's all that means. So, same idea, but what's going to change a little bit here is that we're going to have this point out on the axis of symmetry. This is going to be called the focus. A parabola is always going to open up towards its focus. It's what it's looking at. This is why eyeglasses work. Because it's because of the way that if you think about your eye, the back of your eye where the light comes in, it bounces off stuff, and when it comes back out, the curvature of a glass is allowing it to focus something to be a clear image. That's how this works. What's that?
Do you have a diagram of that?
I probably do. Yes, you do.
Since you don't have a diagram right now, you need my glasses.
Oh yeah, no, and everybody can picture the idea of how eyeglasses are curved a little bit. What happens is in the back of your eye, light comes in and it bounces out. If it's off, if where it's off a little bit, the eyeglass helps it to move that light refractment to make it a clearer image. That's why these things work. Now, if you take your glasses, anybody's got glasses on, you move it out a little bit further, it gets fuzzy. You move it in a little bit closer, it probably gets fuzzy again. If you move it off to the side a little bit, it moves a little fuzzy, all right? Because it's no longer directed at that focal point. That's where the terms come from, okay? I know, math. Who would have thunk it, right? So what happens here is that not only is there this point value that your parabola is always looking at, in order to keep it counterbalanced or keep it balanced out, there's also a value that's behind it. And this is called a directrix.
Gotta find the focus in the directrix.
There's what we call
It had a bad word in it.
every single parabola is going to have this focus and a directrix. The parabola will always open to the focus because it's always trying to focus on something. The curve's always trying to look at something. And then this part behind it is kind of like keeping it balanced. Now I want you to notice something. This directrix is always going to be a line that is perpendicular to the axis of symmetry. And it's back to that. Yes, ma'am?
Is the focus is it like the dead middle of the parabola?
No, this focus point, I'm glad you asked, this focus point is a value such that every point on the curve is equidistant. Mm-hmm.
So it's kind of like the dead middle of the
But all right, I see where you're going. I see where you're going with that. What was that, perpendicular, remember how if a point lies in the perpendicular bisector of a segment?
Geometry.
That point is always equidistant to the endpoints?
Yeah.
It's kind of like that.
So one of those rules that we
It's one of those.
memorize.
It's one of those rule things. It's actually. You know what? I'm sorry. I misspoke this. I'm thinking of something else. This value here, when you go from the focus to the point and the point to the directrix, those are the points that are the same. So this is a bad diagram. The distance from focus to parabola to directrix, those two distances are always the same. Not to the point. I was thinking of something else.
So from focus to parabola, those do not look equidistant at all.
Not drawn to scale.
Wait,
Sir.
so then, I'm sorry.
So the focus and the directrix Is it like the focus to the parabola is the same as the parabola to the directrix?
Yes.
Okay.
And that's how these things work. That's how they keep themselves balanced through. I was thinking of that altitude hypotenuse thing for some stupid reason instead
I
of
was
that.
like, those are like triangles.
Yeah. So what happens here is that this directrix is always behind our vertex. Our vertex is still going to be a maximum or a minimum because it's up like a cup or down like a frown. But what we're going to talk about today is also parabolas that go to the right and to the left.
So the directrix would be y-axis.
Bless you. So what happens here is that you have 4 versions of parabola. Up like a cup, down like a frown, right like a kite, left.
Shell.
I don't know. I got nothing for left and right. Okay. So here's what we're gonna do. What we're gonna do. I'm trying to remember. See if I want to go through all the. I don't really make all these things like this. This distance, we have a vertex to a focus. The distance from your vertex to your focus is what we call P. P is the distance from vertex to focus. Yes, and there's a reason that I do that. Because the reason that I do that is that I draw it like that. Why? Because a lot of
It
times
looks pretty.
what we have here is that if I know that this distance is 3, that means this distance has to be 3. I'm just moving it out of the way.
Because focus to parabola, from parabola to directrix is equidistant.
Correct.
That makes sense.
And focus, those guys are always going to either be on the same vertical line or the same horizontal line, dependent upon whether it's a. It doesn't have to be. It's just you have. The reason that I draw things a little bit weird, not just because I'm weird, no, because that way when we get into looking at an ellipse tomorrow, when I draw out an ellipse and I have to label out all my different point values that I have, you're going to be able to see that this distance is different from this distance to this distance to this distance. It's easier to write it out that way. That's what I'm getting at.
Draw the dashed line.
Yeah, it's just a cleaner draw. That's all.
I have a question.
Yeah.
Is it pronounced ellipse or ellipse?
Yes. So this p-value is always going to be your distance from your vertex to focus. If it's up like a cup, your p-value will always be positive. Now, if that distance from vertex to focus is your p-value, the opposite of p would be your distance from your vertex to your directrix. It's going the other direction. So the opposite of p is the distance from the vertex to directrix. Got the C. So what we want to look at, and I'm just going to start this with just a very simple x squared parabola, and then we'll get into the different variances of it in terms of opposite of a or negative a, and then we'll turn it left and right. Yes, ma'am?
Wait, if P is your distance from your vertex to your focus,
Mhm.
and wouldn't the distance from your vertex to your directrix be just P?
But it's going the other direction. So if it's from vertex to focus is 3, it's negative 3 the other way. That's all that means.
Oh,
Okay. So if this goes up 3, that means this went down 3.
yeah, but they're just the same distance.
Correct.
Okay.
Yes, sir.
So the distance between the directrix and the focus is 2p.
Yes. And what happens at the midpoint of that?
Vertex.
And that's the idea. Okay? Look at that. So if we look at the generic, real generic x squared parabola, we're going to get this formula for parabolas today. Y equals 4px squared. That's what we're going to start with today for a generic form. Excuse me. Oh, that's the old book. That's the new book, right? That's right. The new book does it this way. It does it that way. The old book does it the other way. Yeah, the new book does it this way. I'm gonna use the old book method because the old book method is the one that has it in your calculator. Sorry, I'm gonna rewrite it backwards. The new book does it the other way, and I want to make sure that in this section I'm gonna mirror the old book because this formula is the one that's in your calculator. It's the one that I'm going to give you guys instead of using the new version of it because it's not in there. Does that make sense? So we're going to mix old and new books today. Yay. All right. Yes, ma'am.
I thought it was y equals 4px.
Yeah, I was gonna say.
I just explained why I flipped it
Oh, I was
because
still writing it down.
yeah. Again, the new book writes it that way. I'm going back to the other format for the old book because this is the formula that's in your calculator.
Okay.
So what happens here is that what we're going to do in order to figure out little bits and pieces is that we do a very minimal amount of math to work with these things. Okay. When you have an up like a cup parabola, let me move this around. So we have an up like a cup parabola because it's an x squared. What's the equation of the directrix going to be? Is it going to be x equals a number or y equals a number? What's the equation of every horizontal line?
X, Y? No. Y zero?
Every single horizontal line is y equals some number. So your directrix is always going to be, there's always going to be y equals some number.
But it's the x-axis.
It's not the x-axis. I'm not on an x-axis. What doesn't change when you're graphing a line? When you're graphing a line, when you're graphing a horizontal line, I'll show you here. If I graph a horizontal line,
Y axis.
Oh, that's right, because X is always.
the y value never changes.
Oh, yeah, the Y really. Wait.
Yeah. Horizontal lines, the y values never change. Okay, that's why we write it like that.
Wait.
Wait, I need to write that down.
Okay.
I tried to put that equation into this,
I don't even want you to bother with the calculator right now because most of these things we're gonna use the formula, but what we're gonna do is we're gonna crank things out by hand because it's easier. Okay? You'll have to trust me on this one. So we have the x squareds for up and down. We have then y squareds for parabolas that go left and right. So if I have a parabola opening to the right, do you think that p-value would be positive or negative? Positive. Going to the right is positive, going to the left is negative. So that means that you're, oops, redraw that. So p is still positive, because it's going to the right. Your directrix, going this way, is a vertical line. The equation of every single vertical line is going to be,
Y equals X.
no, that's a line that has a slope of 1.
X equals
Y equals 0.
No, that's y, x equals some number.
Yeah.
Okay. Well, you even say 0.
Wait, I thought that the parabola was up.
Or it could be left and right because now we have a y squared.
I thought that was little ellipses.
Nope, ellipses are squished circles.
A high road.
Ellipses are squished circles. Hyperbolas are,
Oh, two together.
correct. Okay.
I thought we were solving the other one.
Well, we're just starting, I'm just writing these things out. I'm just starting with this, okay? So what's gonna happen here is that it's the same idea, is that this p-value is still the distance from vertex to focus. And then the opposite of p is the distance from vertex to directrix. Okay. So what we're going to get then is that we're going to get an equation, and then we're going to graph it, and we're going to label the focus, vertex, and directrix. To start with it, we're going to place everything at the origin. So our vertex for all of these are going to be where? 0, 0. Okay. Eventually, we'll add some h and k to it, some horizontal and some vertical shift to it. But for now, we'll just place it at the origin. Okay. The dumbest thing in the world, but it works, doesn't it? It's great. So let's look. Let's see, I had it. Now you have all this now written down, I believe. This is a little cheat sheet as far as where things are going. The generic forms, whether they are up like a cup, this is x squared, or down like a frown, x squared, left, ones that open to the right, or ones that open to the left, things like that. For today, since everything's going to be centered where they are, they're going to be placed at the origin. If I'm up like a cup, my focus moves upwards. So what's changing? The y value. That's why the focus will be at 0, comma p. Now, as we start to shift them, once we know where our center is, it's just a matter of moving it vertical from wherever your order pairs. It works out to be very, very easy to do. It's just the language part of this and what this p-value represents. Tomorrow, what the a values and the b values and then eventually the c values, what all of those represent is what takes a second to get used to. Walking and placing these things in space become very, very easy. Okay. So this is in the old book. It's in 10.2. It's already uploaded for you guys, I think. I'll make sure it is. And then we'll go from there. But let me show you an example because I don't think we have that much time. Let's graph the following.
Hey, is that old book, the diagram?
Yeah, it's all in the, this is, I'm using 10.2, I'm going to use out of the old book because they don't use, they still use the same formulas that are in your calculator, and I want to keep them all the same. I don't want to have to switch back and forth between the two different formats. There's nothing wrong with the other format, but it gets a little messy when it comes into play with the shift and stuff, because it's just not good. So let's look at this. We have an x equals negative 1/6 y squared. Excuse me. Which means we have, is it going to be an x squared or a y squared parabola?
X squared? Wait,
Well-
but how come the equation isn't like, I thought that the two options were x squared equals 4py or y squared equals 4px, not.
So what do you have to get by itself? Y squared.
Oh, so it's y
Negative
squared equals negative 1/6x?
Well, here's what happens. We agreed that we have a y squared parabola, correct? The generic form, and you're right, the generic form says y squared equals 4px. That's our formula. We need to make it look like that. So how do you move a negative 1/6? Multiply by negative 6. Which means in this case here I get negative 6x equals y squared. We're okay with that? Now, for sake of argument, I'm just going to rewrite it as y squared equals negative 6x. Is that okay?
Yeah.
What direction is this opening?
Down like, no, wait, no.
Right.
It's a y squared parabola. So it's opening left because this is negative. So here's what I'm always going to do. I'm going to ask that question first, depending upon, well, obviously with every one of the conics that we look like, or that we're looking at, the one thing we're going to be able to tell right away is what direction they're opening. This has to open to the left because two things. It's a y-squared parabola, so it's either go left or right. It's left because it's negative. I'm always going to draw this first. That way I know that's what it's going to look like, some shape or form. So later on, I can go back and say, hey, that's kind of what it looked like when I took a guess.
Wait, why is it -6, not +6? You multiply it,
What's 1 times -6?
Oh, it's +1?
Yeah.
Because
Because it's just x equals -1/6 y squared. I have to get rid of the -1/6 here, so to multiply by -1/6. Well, it must multiply by -6. So now here, I have this represents what in there?
P?
4p.
Oh.
So that means that -6 equals the 4p. Therefore, what is p? So my p value is -3/2. So that means that I have a parabola that's centered at the origin today. My vertex is at 0, 0. I have a p-value out 1.5 from there. So my focus has an ordered pair of -3/2, comma, 0. I have a directrix going the same distance the other way. 1.5, but it's a vertical line. So what's the equation of my directrix? So it's going, I moved, this way I went 3/2, this way I went 3/2. So the equation of the directrix is x equals 3/2. And it has to open, and you're done. That's it. That's what that would look like. Identify where the directrix, where the focus, and the vertex is. Today, vertices will be at the origin. What we're going to do is we're going to try and figure out what this value of p is and go from there. And it basically works out to be the exact same thing over and over and over again. It's just moving to the different spots, right?
And is it always gonna be, is y? Oh, wait a sec, wait, is the ordered pair always gonna have one be 0?
Today, yes, because we're at the origin.
Okay.
And then even if we shifted it, if you think about it, if we shifted it, and let's say this was at 2 and 1. If I went up, this would be at 2 and 4. And then this would be at, well, this is 2, 1, this would be y equals -1. So all you're doing is you're just moving up and down off of this ordered pair from wherever it goes. Whether it's up, down, left, right, it does the same thing. That's the idea of knowing what these values do. Okay? And using this formula versus the other book, the newer book, is just cleaner than this one.
Also, why did you move 1/2 and not 3/2?
What's 3/2? 1.5.
Oh, 1 and you moved 1.5. I thought you moved just 1.
Wait, so what's like, you don't have to find like the slopes per se? Like,
That's
how do you
pre-calc.
calculate that? Or like
Where-
the X and Y value? I don't know, you were saying something like that. How, yeah, so we don't have to find the slope.
No, you're not gonna find, the slope here is undefined. The slope will be at 0 because it's just horizontal and vertical lines. That's all we're worried about that. You don't have to worry about slopes. You will, all right, I shouldn't say that. You will find slopes and you will write equations of lines when we start talking about diagonal asymptotes in hyperbolas.
But we don't have to find the slope. And I don't even know if it's called slope, but you know what I'm talking about, like how wide the parabola
No.
and
No, we're not gonna worry about that because I'm just doing a generic idea of where it's setting itself up. That's all, okay? Let's try another one. So x equals 3/4 y squared.
Some yellow, some
Graph paper, schmaff paper, we don't need no stinking graph paper. Is this an x squared or a y squared hyperbola?
y squared,
And why is it a y squared?
this is a y squared.
Because there's a y squared.
Why didn't you just originally set it up? Why do we do that little step to change it?
Because this is how the problem's being given to you.
So then you have to multiply them by 4, and
Bless you.
then you get
See-
y squared equals 3x, 4x, I mean, 4, oh, just,
So y squared is going to equal 4/3 x. What does that 4/3 represent?
It's
4p. Now, first of all, does this open up, down, left, or right? It's going to open to the right. It's y squared, and it's positive, so I know it's going to have to do this. So now I take the 4/3, and I set that equal to 4p. Nope. How do you undo multiplying by 4? Multiply by 1/4, or divide by 4. If I multiply this by 1/4, you get 1/3 for p. A lot of very subtle fraction things you're going to work with. Okay? So now we know it opens to the right. We have a p value of 1/3. So origin's at the vertex today. If I just put my p value here and call that ordered pair, what would that ordered pair be? 1/3 and 0, yes. And I have to go back this way to make my directrix. The directrix is going to be, is it going to be a vertical or a horizontal line for this problem?
okay, 1/3
Vertical.
and 0 is the focus, right?
Yep, it's going to be a vertical line. And that vertical line always has the equation of, in this case, it's going to be x equals negative 1/3, because it's on the other side, and it opens to the right. And you're done. Your focus is at x equals a number. Excuse me. Your focus is at the 1/3 comma 0. It just moved to the right of the origin. Your directrix is a vertical line. Vertical lines are always x equals a number. Also, one thing you'll notice is that the directrix, every time, it would technically go through the parabola at 2 points. Does that make sense? That way you always remember which way it's going to go. Let's see here.
How did you know we did parabola 2?
If it moved, it would go through in 2 spots. This would go through, it would slice it in 2 spots. That's all I'm getting. Let's do this. Yeah.
Alright, I was
We
gonna
got-
say it's been the same time for the past, like.
I mean, I know time really flies when you're in this class, but we got about 10 minutes.
Oh, okay. Well, I always think
So
about that.
let's write the equation in standard form with the vertex at 0, 0, and the given directrix. So today, all of our points are going to be centered at the origin. So if I'm centered at the origin, and I have a directrix of y equals 2, if that's y equals 2, what direction is this opening? Down, very good. It's opening downward because the parabola is going to open opposite of where the directrix is. Now, if it's down like a frown, is that an x squared or a y squared parabola?
Why?
It's going to be an x squared parabola. So it's going to have to be an x squared equals a 4py. And what we know, careful, is it a positive or negative 2? It's negative 2 because from the verb, correct. Since our directrix, you okay? Since we know this has to open downward, it has to be a negative. And remember, your p value is always the distance from your vertex to directrix. negative. So our distance here is -2. Okay, so the p-value is -2, because I went up here, which means the other one would be here.
Focus is 0, -2.
Yes, the focus would be at 0, -2, so that means our p-value is -2. So this would be x squared equals 4 times -2y, otherwise known as x squared equals -8y. And that's what that would look like. Write the equation given the following value. Do you start to see this is why I use that little squiggle now? That's when I'm counting around, because that way I'm not on that axis of symmetry. It's cleaner. Okay? I think you're the first person that's ever asked me why I do that. Plus, it really, when we get into the other stuff, it looks really cool when you have all these diagonals going all over the place, or the squigglies. It looks awesome. I'm easily amused. Look at Doug. We were at a store this weekend. I don't remember which one it was.
So all you need is the directions.
Pretty much. And our oldest son, there was like a wicker squirrel. So he had it, he held it up, he goes, squirrel! Squirrel! It was awesome. No, let's do another one.
Is Ryan the moose or is Connor moose?
Ryan's the moose.
Okay.
Ryan's the moose.
Oh yeah, because my mom said she had Connor in her class and she didn't.
Centered at the origin with a focus at 0, -3. Let's write the equation. Centered at the origin with a focus at 0, -3. What's the first thing you should do? Plot it. We know that everything's going to be centered at the origin today. So my vertex is at the origin. My focus is going to be at 0 and -3.
So then that means that the directrix is going to be 3.
The directions will be at y equals 3. What direction is this going to open?
Down.
Down. This is going to open downward, which means the p-value is what? -3. So my generic is going to be x squared equals 4py. In this case, p is -3. X squared equals -12y. Okay? Because eventually we'll be able to write these equations. If you have a parabola and a vertex of 1, -2, and a focus at 1, 1, where they're going to give you the ordered pairs, and you'll have to place it in space to figure out the directions of it. They're really not going to be that terrible. So let's see here. I thought I had us doing this, but I think that seems to be too much. Well, 1777 every other odd. That's not bad.
Wait, how come when you do the actual equation, like you use the y from the
What's that?
Like how come when you're writing the equation,
Yeah.
you use like the y from the focus and not the direction?
Because in this case here, that's where it was placed. So when it moved from the origin to here, we
Is
knew
that
it's
what the equation is using?
because your vertex is going to be at 0, 0. So what will happen is if we have a vertex at 1, 1 and a focus at 1, -4, you'll know that when you graph it, that 1, 1 is here, and the other one's at 1, -4. If your focus is there, that means it's opening this way. And then how far is it? 1 little, 2 little, 3 little spots, 4 little, 5. The p then is -5. And you'll from there. That's what we're getting towards, but not yet.
And then we're just still starting with the vertex.
Yeah. Yeah, this is good because there's only like 4 of the little graphs here, but a lot of it is up, down, left, right. What's the focus? What's the directrix?
17 to 77.
Every other odd. It's every 4th. It's like 18.
That's like 100.
It's not 100. It's not. It is not even close to that many, you babies. Let me make sure I have this uploaded.